Today, I'm very happy to welcome Andrew Costello to the AFSA podcast. Thank you for joining us, Andrew. Andrew is a strategic consultant at IMRA, which is the International Medical Robotics Academy based out of Melbourne. Welcome, Andrew.
Thank you, Rachel. Very nice to be with you this morning.
So I'm going to start off with a question. Can you introduce IMRA and the programs you offer to our listeners?
Sure. IMRA Surgical is a company that has two sort of business streams. The first is an education practice where we have various robot platforms. So that the three major ones that are in Australia at the moment being the Medtronic Hugo, the Intuitive Da Vinci, and the CMR Versius, which comes in and out of our facility. So we use these to bring surgeons into the facility to train using these latest robotic platforms with our synthetic organs. We also use virtual reality and surgical science simulators. So these mimic the console setups for robotic surgery. So it's a way, and that part of the business is a way for surgeons to train safely away from patients using simulators, VR, and synthetic tissues. We also run a lot of online courses, and we've developed recently a franchise model which has expanded into Ireland and into the Guy's and St Thomas hospitals and the NHS in the UK.
Brilliant.
Yeah, it's going quite well, and there's a real appetite for these kind of courses which train surgeons where there are. So a big advantage of our stuff is that you can send some of this surgical tissue into the operating theatres and use it. But the other part of the business is creating synthetic tissue. So we make a very lifelike torso model of both male, female, as well as an infant model. The Hydra and Logan and the Piccolo model. So these are used as replacements for cadavers, which are commonly used in surgical training, and into which can be inserted various procedural models. So we make really high fidelity synthetic tissue for such procedures such as partial nephrectomy, where they're excising tumours from a kidney, or a prostatectomy, or a hysterectomy, or a gallbladder and colon surgery as well. So these models are made from a hydrogel material, and IMRA Surgical's set up a Pindari arm, which is the Pindari surgical synthetic models, and was really over the last 6 to 12 months become a manufacturing business in one sense, because we're getting huge orders from big industry players in medtech like Johnson & Johnson and Medtronic, as well as some of the new robotic vendors like Vicarious Surgical, Intuitive, who are looking to replace the use of live animals when they train surgeons.
Well, thank you very much for that introduction. We'll delve a little bit deeper into the models later on. But for now, could you outline your personal journey to working for IMRA?
Absolutely. Mine's a bit of a circuitous journey. I was an archaeologist for about 15 years. I worked for a big international engineering company actually called Jacobs, which are based in the US. And they bought a company, SKM, that I was working for. So that experience working closely with Aboriginal people in Australia to identify significant and historical and archaeological sites that may be impacted by development was really my introduction into project management and working with highly technical teams. I worked in the environmental science division, where we had ecologists, hydrologists, land rehabilitation specialists, contaminated land, and archaeological and heritage practitioners. So running big projects for bridges, tunnels, all energy, water, huge projects across Australia that really transformed the landscape, put me in a position where I was managing big projects, managing really smart people, sending them into remote and sometimes potentially dangerous situations where we'd go out into, really remote areas of Western Queensland or Papua New Guinea or into Torres Strait and conduct archaeological excavations. And so that sort of experience as an archaeologist showed to me that I didn't quite have the language to talk to the executive teams at a massive multinational like Jacobs, where there's 90,000 global employees. So I did an MBA back in 2017. And about that time, my father, Professor Tony Costello, who's one of the world's leading surgeons, especially in urology and robotics,
Yes. Yep.
had a brilliant idea to create a new training paradigm for surgeons. And my brother, Dr. Dan Costello, who's a surgical trainee, was also involved, and we'd sit around and discuss this idea. And then I sort of started applying some of these concepts in my sort of business administration studies, and it seemed to work out. So I made a big switch to help found this company. Around 2018, we got some money from the government, which was from the Victorian state government, to set up the Centre of Excellence, which is in North Melbourne, part of the Parkville Biomedical Precinct. And then it was just, a fast-paced deep dive into startup and med tech for me. The good thing for me was no one's really doing this at the time. Synthetic tissues hadn't really reached a stage where they could compete with the fidelity that you got from using cadavers or live animals. So we were really up against it, trying to convince the world that it was time for a change. And that sort of took me through to the end of last year when, as I mentioned before, IMRA became really a manufacturing company. And with that comes a whole lot of new skill sets in engineering processes, quality control, and that was going to be a deep dive that was a bit too far for me. So with the board's approval, I took a redundancy and maintained my role as a strategic advisor, but we recruited a fantastic head of product development from the medtech business who's running that now. And it continues to grow from strength to strength. We're getting big purchase orders from Johnson & Johnson and other global players who I think are recognizing that the time is now to phase out the use of animals in surgical training.
Yes. Well, thank you for that. Yeah, really insightful background. It's a bit of a crossover and must have been a huge challenge, but obviously got IMRA to the point where it is today. So been hugely successful. So really interesting to hear that background, and obviously a very talented family
Thanks.
history there. So you have touched on, sorry.
I'll just go back a bit further. So my grandfather, who lived to be 100 and passed away just a few years ago, was a general practitioner, but also he was a pilot in the in World War II, and he was part of the Z Specials, which were a special operations group from which was born the SAS. So he was involved in aviation as well as being a doctor. And part of IMRA's success is that we've taken a lot of the learnings from aviation simulation, and they had really led the way in reducing adverse events in airline safety by applying simulation. And
Yes.
my dad, having had that background as a father who was a pilot and a doctor, realized that we could learn a lot from that, and applying that to a high performance people like surgeons in high impact situations with high consequences. There's not a great way to train where everything you do has such a high consequence, but if you can take them away, put them in a simulated environment where they can practice those procedures without the risk of a catastrophic failure, you actually learn a lot better. And there's a lot of metrics around this from the aviation industry, which we've been able to bring over into surgical education and training. So, I come from a long history of medical and surgical specialists. I've got an uncle that's an anaesthetist, another that's an ENT surgeon, a pediatric surgeon. My cousin runs the Western Hospital cardiology unit. His wife's a pathologist, and my other cousin's an anesthesiologist. So it's kind of in my blood. And
Yes.
I worked on those when my father brought the first robot to the Southern Hemisphere at the Epworth Hospital back in 2002. I was working as a theatre technician, studying archaeology, reading my textbooks in the operating theatre while we did these long robotic cases, which back then would take 6 to 8 to 10 hours, which now take under 2 hours. So it's been a journey with my family, but with this amazing robotic technology that's really the future of surgical procedures and interventions.
Thank you. Yeah, it's pretty amazing that link with the aeronautical industry. And I do recall colleagues who've been to the surgical robotics conference mentioning that, and it was very interesting to me when they were talking about and the parallels there. So it's it's just what you might think would be one subject, but relates to so many other areas.
That's true. It's about
Fascinating. Yeah.
Yeah, and what we've discovered is that, human factors in these high pressure environments are so important, particularly when you add robots where the surgeon's often looking into a console, he's not at the patient's side. So that means there's a whole new way of communicating where it's not as it's not just language, the sort of the body language and the eye contact's taken away a fair bit. So the surgeon has to learn how to take control of a theatre without having that sort of physical and eye contact presence. And so we train a lot of that, and we have the chief of simulation, Captain Matt Gray from Qantas, who takes our workshops and courses, and the feedback we get from surgeons is really extraordinary. They just find it when we run these simulations. So we have an operating theatre that looks like an operating theatre of the robot, and we have actors and people like myself playing technicians and nurses and anaesthetists. You really get quickly into what feels like a real situation, and then we add adverse events. We make the patient have a heart complication, and they have to undock the robot. So what we find from the surgeons is training like that really gives them that muscle memory for when it happens in real life. But in the way we do it, no one's been harmed in the process, and I think that's going to be the way of the future.
Yeah, definitely. And I think, yeah, that will help our listeners visualize a little bit more about what that training involves, because it's hard to kind of understand it from a description. But yeah, it is a simulated situation.
Yeah.
So you did mention that there has been a positive response. So how in general would you say the Australian teaching hospitals or training centres have responded since your establishment? What is the current demand? Has it grown in recent times?
It's been a great reception so far. So one fantastic achievement we've managed to do is we've launched the first comprehensive robotics discovery course at Melbourne University at medical students, not surgical trainees. And that's
Yep.
because, this wave of technology, which includes AI and machine learning and robotics and telerobotics and telehealth and digital health, is really being embraced by the younger generations. And so introducing an experience where the students will get to come over and use simulators and robotics and synthetic tissues has been really well received. So that's been great. And we found that other big training institutions like the Ingham Institute for Applied Medical Research in New South Wales has joined us in a partnership where we have sort of training the trainer so they can set up their own version of IMRA, an IMRA franchise up there in New South Wales with great response. And then we've had some, as I mentioned before, some global wins with the Royal College of Surgeons in Ireland, who've adopted our online and synthetic tissue training models. They're a very innovative college. They do a lot of work in the global south, in Africa, training surgeons, as well as in Bahrain. So that's opened up a whole global network for us. I think some of the other hospitals more locally, the Grampians Health installed a robot in their Ballarat hospital, and we were able to take up what we call a greenfield site, in that there was no robotically trained surgeons there, and over about 4 to 6 months, bring them up to the stage they're at today, where they're performing, up to 10 or to 12 robotic surgical procedures there safely and efficaciously. That involved bringing them to Melbourne for some simulator work, and then sending simulators and proctors, which are medical mentors and surgical mentors, up to Ballarat. We've been working a little bit with the Royal Melbourne Hospital, who've got a Medtronic Hugo robot installed to teach them. But I think there's a broader issue around the public health system, the initial cost for robots, which is coming down a little bit, but we see there's still a lot of work to be done. We've written a template for how you take a hospital program that doesn't have a lot of robotic experience and get them up to speed more quickly using online VR simulators and then proctoring. and we ascribe to what we call a proficiency-based progression. So it's not about doing the numbers. You've done 3 of these procedures, you're good to go. It's about, have you hit the benchmarks that prove that you're up with in the bell curve of where you should be before you see your first patient. And what we found is this is challenging to some of the ways that robotic surgery has been taught in the past, where it's very vendor driven. And of course, the robotic vendors have a real mandate to sell robots. And so they weren't always as comprehensive in the training. And we think that that should be taken away from the vendors, given to the states or the hospitals to set their own benchmarks. And then IMRA Surgical can provide the education platform and all the curriculum to make sure that, you know, the patients in the end get the best outcome because their surgeons have been well trained. They're familiar with the robot, they're familiar with the operating room and how to communicate effectively, what to do in adverse events, and they've done a whole bunch of training on simulation so that they are well equipped to handle whatever might come up when they operating on their first patients.
Yeah, that sounds like the much safer and more sensible approach. So hopefully there'll be some adaptation to that. So from AFSA's perspective, we often find sometimes that one of the obstacles to transitioning from animal to non-animal models in teaching and research is validation and the process of validating the non-animal methods. So I understand IMRA is in the process of submitting articles for publication, which details validation of your training programs. Can you outline the key findings and what the validation process is for non-animal surgical methods to be accepted?
Yeah, it's a comprehensive path, and it always takes longer when you're validating research in an academic journal. So we've appointed our Director of Clinical Research, Dr. Helen Mohan, who is a colorectal surgeon. She's also just a weapon. She's she's got 4 kids. She writes research papers. She leads a lot of our workshops, and she has a busy clinical practice. But she has really directed our research. So we're still in the moment of gathering information. We have a couple of papers that will be published shortly. I think what we're looking at, after the Society of Robotic Surgery conference, which was held in Melbourne here, and IMRA were the local hosts, we had a Delphi consensus meeting where we got a whole lot of the world's foremost robotic surgeons and sat down over a couple of days and a couple of big sessions to decide what is the best way to train a surgeon in robotics. Now, industry are invited to participate, which they should be. And there were some standards and discussions set, but that Delphi consensus is going through its final rounds of approval, and that will come out and lay a template, which will definitely include synthetic tissues and simulation. And that will be published soon. The other work we're doing, importantly, is some work with RMIT and their computer science team in what are the metrics that you need to measure to see how progression and proficiency is being undertaken by surgeons. So that looks at, if we have let's say a radical prostatectomy tissue model, what are the steps in there that we can measure to say you've passed or failed, or you've completed this in time or not? And what are the benchmarks set by expert surgeons? So what level do you have to get to? And that takes time to get busy surgeons to undertake trainings. First, you've got to get the experts to do it. Then you've got to get the intermediates and the novices and get some meaningful data from them. So that's underway, and we have a few papers in that area. What we aim to do is publish in all the different surgical specialties to set those benchmarks and then set the education or curriculum standard through simulation to what they have to do. So I guess the validation process is really getting a wide range of surgeons of different surgical abilities, see what particular aspects of the procedures sort of stand out as areas that a lot of surgeons need improving on. And then we've designed synthetic models that may be 1 or 2 steps, but maybe the difficult part of the surgery that they really need to practice on. So when you're looking at a cadaveric or a live animal model, you sort of have a one shot. It's a single training event. You get what you get. It's, obviously with cadavers, it's not the real thing. They're not bleeding. They're embalmed with all of those horrible chemicals to keep them preserved. And with animals, they just don't have the anatomy. So you're already compromising the sort of fidelity of it. But what we found is not everyone needs to jump straight into a total hysterectomy model. If you're a surgeon that has never done it robotically, we think we can start with what we classify as a class 2 model. And that's another paper actually we're publishing is on the classification of synthetic models. And we've developed a class system based on whitewater rafting. So you can imagine class 1 is a nice stream that you just gently float down, and a class 7 is a rapid that you probably shouldn't be attempting to handle in your canoe. So we base that on, we have a class 1 or 2 model will be a couple of, maybe one organ with a couple of procedural steps. And then we load that right up to a class 6 or 7 where it's a fully bleeding model that you can use surgical energy on. It has the full procedure and organs, as well as the accompanying organs and vascular systems. And that would take, 45 to an hour. And that's all the surgical steps you need to perform that procedure on a human. And so we break that down. If you're a novice surgeon, you might just do for a hysterectomy, the colpotomy and cuff closure, which is a challenging step. You've got to connect 2 ends of a tube using sutures. So you might want to spend 2 or 3 episodes training on that particular model before you go into a class 3, which will have a few other surgical steps. So it's a way that we can meet the surgeons where their training is at and focus on the areas they need to improve. And again, we'll have them benchmarked. So after the 3rd one, you'll know if you're sort of measuring up to what the standards are of care by the expert and intermediate surgeons of the world.
Yeah, thank you. So I've read some viewpoints expressed that virtual reality models can cause dizziness or nausea. Is there any accuracy to that claim?
I'm quite a VR enthusiast. I definitely, when you're playing on the mountain climbing games, you can feel very dizzy if you accidentally fall off the mountain. It's amazing how quickly you're transported into that simulated environment. We use VR mainly to show surgeons an annotated and narrated version of a real procedure. So we take the footage from the back of the robots, we put it into a VR headset. So it really looks as though you're staring down the lenses of the robotic console. And then we have expert surgeons go through that. We have, annotated notes that will pop up. We'll have images and diagrams to explain the anatomy, which is quite different from open surgery. So we show tissue planes, and then we get the surgeon to describe different steps as they go through the procedure. What we found is you can stay on those for ages, as long as you're sitting down and fairly safe. We find that surgeons, first of all, love to watch these, then they like to watch their own, and then they like to compare their technique to other surgeons, and no 2 surgeons are the same. So we haven't found that dizziness or nausea is an issue. Maybe that is for some people. We certainly haven't seen it in ours, but it is just a great way to show someone that's never seen a robotically performed, say, radical prostatectomy, get some of the world's best experts to talk them through step by step, and that might be for 45 minutes or an hour. We find the surgeons want to jump onto the next one and see a cholecystectomy or something else. So there's been no problems from our perspective.
Thank you. And you've mentioned this in some of the previous questions. For the benefit of our listeners, in terms of animals used in surgical training, it would typically be pigs or sheep. What advantage would you say that the robotic surgery education IMRA offers over these animal-based training?
Yeah, there's a few really key advantages. I think the first one is that a robot at the moment goes from about 2 to 4 million. And if you've used one of these robots on an animal, it can no longer be used in a clinical setting. It has to become a training robot. So that's a very expensive piece of training equipment to have a $4 million robot that cannot be used on a human. So our bioinert synthetic tissue means that we can send our synthetics and simulations and torsos into the operating theatre. So that means at the end of a list, if they can wipe down some of the surgical instruments and undertake a training exercise. So that's a huge advantage for time-poor surgeons that in the past would need to fly to the New South Wales RPA to do a pig lab, or take time out to go somewhere else. And so we think that's a huge advantage. The other part is we make ours really anatomically accurate. So they're exactly the look and feel of tissue. For example, our partial nephrectomy model has been taken from a patient CT scan and 3D printed using a phantom. So the tumor itself is of a different recipe and formula, so it feels of a different consistency to that of the fat and connective tissues that we put around there. So it's a much higher fidelity and much more accurate. We don't always make them identical to anatomy, because what we've discovered in all the extensive consultation with surgeons that we've had, they don't need these to be anatomically accurate 100%. They'd rather augment or enhance some of the training aspects. So we've elongated some parts so that a surgeon can have 2 goes at a particular procedure as part of the one training event. And that's through, I guess, the benefit of having a world-class facility like ours that has surgeons coming in and out. We can put on the table a prototype and say, what do you think of this, gallbladder, or what do you think of this colon model? And they might say, oh, it's great, but I wish I could repeat that again. And that's how we get that insights to augment, enhance some parts of the anatomy to make the training experience more beneficial for the time-poor surgeons. I think the other massive one is cost. The cost to get cadavers, the cost to get animals is really expensive. With the pigs and porcines, they've got to get a veterinarian in, they've got to get an anaesthetist,
Yes.
not to mention the sort of, in my mind, the sort of waste of an animal that has to be euthanized at the end of it. And then that all costs a lot of money. With our torso, the female version is called the Hydra. The skin is resealable. So after you've performed the surgery, you can use a heat gun and heal that again, and that can be used up to 500 times. So it's a lot more sustainable. It can be used where in the operating theatres, you can send them out and have them for when surgeons get some time, they can perform them. And so I think they're some of the main advantages: the cost and the time that we save to surgeons, plus the repeatability and accuracy of the models.
Yes, that all makes sense. And the high fidelity synthetic human organ models that you create, what are they made from?
They're made from polyvinyl alcohol, which is a pretty common sort of material that's used a lot in glues and gels. So I think the reason we were able to get them is there's some secret herbs and spices in there, as well as some processes. It's a freeze-thaw process, and you can adjust that to create different hardnesses and densities. We make, it's quite, I think the closest thing would be sort of that molecular gastronomy that Heston Blumenthal does, where each part of the process requires different ingredients and different temperatures and settings. So if we're making a ventral hernia model, which has 6 different layers of tissue and the lineus alba and the rectus sheath and rectus muscles, each of those will have a different recipe and a different process that come together and are put together to create the final model. But you can really sense that when the surgeon's cutting through different tissue planes or using diathermy or electrocautery to cut through them using energy, the fat will sizzle like human fat will do, or normal fat will do, and that's the Maillard effect. Whereas the peritoneum will char like the peritoneum in humans does. So we've taken a lot of time. We work with the Melbourne Uni Biomedical engineering department to run a lot of experiments with their students and master's students and PhD students, as well as a lot of our employees, which have come out of the Melbourne Uni Biomed School, to refine these. And we're constantly looking at ways to improve the density or the sort of look and feel of all of the different anatomical components. So while it's a simple base material that we use, the amount of additives we've used must number into the thousands. We've tried everything from, sugar from the table to diatomaceous earth to all kinds of weird and wonderful additives that, some work and some don't, but we've got a big list of things that do and don't. And we continue to add and refine our ingredients as we move from the pelvis, where we started in urology and gynecology, up through general surgery. We're looking at a lung model now. We're looking at the heart. And I know the hydrogel science team there are looking forward to that lung in particular. It's a spongy model that needs to inflate, and they don't know how quite to create it yet, but they're in the lab, which we have there in North Melbourne, with the Beakers and Bunsons and putting those experiments together.
Yeah, amazing. And you mentioned that the torso model is reusable. Are any of the other synthetic models reusable or have the potential to be reusable?
Well, not yet, but we more so in the sustainability area. We're looking at sort of the circular economy and having our hydrogels being able to be reconstituted and used again in different parts of the organs. But for reuse, we have seen it a little bit. Some of our industry partners will use the same model again for trade shows just to show how their robot works, but they're designed to be single use. So you come in, you put them in the torso as a cassette, you perform the procedure, and then you take that out and replace it with, a more advanced model or repeat the performance again. And they're designed that way. I think so. Each surgeon gets put into that simulation with, either a normal or a diseased human anatomy that they can run that training episode on.
Do you observe any hesitation to embrace the non-animal teaching methods by the surgical profession?
No. Well, I would say no, but I'd preface that by saying it's not the surgeons that are resistant. I think it's those old established models of using animal tissue. And to be fair, you don't want to compromise on surgical training experience. The problem is that the curriculum, the assessments are all based on this outdated model where animals were part of that. So, there's been quite a lot of investment here and overseas in animal labs. And then so to unpack that to say we no longer need to use this as a financial cost, as well as rewriting those curricula and assessments so that you can, qualify a surgeon at the end of it. Now what we found is the younger surgeons, there's a lot more conscious objectors that are just refusing to fly to Sydney to RPA to do a pig lab because they know that there's alternatives. And so it's bringing on the change a lot quicker. It's in the assessment and the accreditation where it's a bit harder because, I think some of our industry partners are rightly trepidatious about switching over until they can be sure that we can meet the market demand. And that's a lot of the reason why IMRA became a manufacturing company. Those numbers go up pretty quickly if you're replacing all of those animal tissues with synthetic. We need to make not just 100, we need to make 10,000 of these a month. And so I think once the industry is reassured the alternatives are sustainable, available, they're consistent, it's the same output each time, I think that switch will happen quite quickly. At the moment, there's kind of this interim market for sort of Frankenstein models where they go to the abattoirs and they stitch together pieces of animal tissue to look more or less like a piece of human anatomy, and they string that up over a frame and they operate on that. That has the same old issues as animal tissues. You can't use a clinical robot on that. You can't export it. It stinks. It goes off very quickly. So really not as advantageous as the synthetic stuff. But until the industry and the accreditors and all those bodies are reassured that they can make the switch, we're still sort of struggling with some of those old models that are harder to budge because of, the entrenched financials and academic pathways.
Yes. I would say from our observations, there seems to be some institutes that are still using them, but at the same time, they are maybe will have half and half. So some of the course will be non-animal methods and some will still be the animal lab for a certain stage of it. So
Yeah,
perhaps
I think
be replaced completely over time.
that's right. The appetite is there to change. They just, a surgeon has to be qualified, and it means rewriting the curriculum.
Yeah,
We're trying to do the hard work by saying we have curriculum ready to go, but there's a lot of change that needs to take place.
yeah,
We see in Royal College of Surgeons in Ireland, their appetite for innovation and change is probably a little stronger than here in Australia. But the Royal College of Surgeons here have made a statement that they will switch out animal tissue as soon as high fidelity synthetics are available. So that's really promising for us.
yes. Yeah, that's I think a big change even from 5 years ago in their positioning. So that's really, really promising.
Yeah,
Um,
absolutely.
and you did mention that you are beginning to expand internationally now. So as well as Ireland, are you aware of any other international trends in surgical training and animal use? And how would you compare Australia with other regions?
I think we're leading the way in some of this stuff. So we've got not only IMRA Surgical, there's other companies here that are developing it in Asia Pacific, in Japan and Korea especially. They're making synthetics. So look, they're competition for us, but we welcome that. The addressable market is huge. Up to a sort of 10,000 animals are euthanized in the US each year for surgical training. And then you can imagine that for the EU and Asia Pacific. So there's a lot of animals we think being unnecessarily euthanized. And so we welcome other companies that are embracing synthetic methods. I think that Australia are sort of okay at the moment. I think the US have made this switch in a lot of their robotics. The big company Intuitive is using what's called kind heart, which is as I described before, they use animal parts and restructure them to create human anatomy. That's just a bridge. You can see that they're trying to go the right way. They're not killing animals. They're reusing parts. So the appetite's there. They just
Yeah.
still can't find the alternative. We hope to fill that gap. I think places like Germany have completely banned the use of animals in surgical training. They won't use a system like they do in the US. And we're
Okay.
working closely with University in Freiburg and Bonn, and they're really keen to see our torsos and tissues being used over there. At the moment, surgeons are flying to places like Orsi Academy in Belgium, where they use a lot of animal tissues to get training because they still have to
Oh,
get training, which is a shame, and
yeah,
you can
that
imagine
surprises me. You think with that ban there would be some German companies that would have sprung up.
it's just if we got orders from all of these places tomorrow, we just wouldn't be able to fulfill them. So
Yeah.
it's on us to create the supply.
Yeah.
We know the demand's there, but it's about getting the consistency and the product numbers up, which is yeah, which is the real challenge. But I think it's coming, and it'll come quite shortly. The more competitors there are in the market making high fidelity synthetics, we welcome that because we think the addressable market is enormous, and we won't be able to fill it on our own. You should have alternatives, and those alternatives should not be animals.
Brilliant. Well, thank you so much for your time, Andrew, and for the work of IMRA. We do have a page on our website about surgical training using animals and non-animals, and we've linked to IMRA's website on that page for any listeners who's interested to find out more. Do you have any social media or any other channels that listeners can follow to find out more about your work?
Yeah, look, we've got the IMRA Surgical LinkedIn page, and some others I'd like to share, but I would like to also add, if there are people interested in training using synthetics, get in touch with us through that page or online on our website, because we'd love to help researchers that want to use synthetic tissues. We're working with some really interesting startups across Melbourne, and it's such a vibrant place at the moment in the medtech space. Companies like Polynovo, who are designing tissues, synthetic tissues to improve burn wounds, and other amazing startups that sort of can connect. So if there's researchers that are looking for products to use that react like human tissue, we'd love to get in touch with them and hear about what they're doing and see if some of the Pindari surgical tissues can be of use in any other aspects of research.
Yeah, I think that's a good point. We've really only discussed surgical training, but there's much broader research application of the synthetic models that you've manufactured. So it could be a whole other conversation.
Yeah.
But thank you so much for your time and for all that IMRA's done and your your personal commitment and career devotion to this. It's amazing to see the pace of technology and what's changed in the last 5 years and what will be changing in the next 5 years and beyond. So thank you so much for your time today.
No problem, Rachel. It's been a pleasure.